Hello, welcome to the video solutions for Unit 6, Lesson 6, Digging It. Ready, set, go. So it says, use the given information to find the missing sides and the missing angles. And it tells us triangle ABC is a right triangle. It tells us that angle C is a right angle, right? So let's add that in there. Here we go, 90 degrees. So, and it tells us write the exact values for the sides. So let's start with angle A, angle B, and angle C. Well, it already told us C is a right angle, so that's 90 degrees. And here we see that it's isosceles, right? So there's only 180 degrees total. We've already used up 90, which means there's 90 more. And since these are isosceles, this is an isosceles triangle, the angles must both be equal, so they must both be 45 degrees, which makes this a special right triangle. Right, we see that's isosceles. So side A. So actually, let's start with, let's label these just to make sure we label. Right, this is side A or BC if we want. Here's side B, and here's side C. So side BC, which I'm going to call side A with a lowercase a, that's going to be the same as side B because it's isosceles. So that's 5. So side B, or AC, right, is also 5. And I know it's inches, so I'll fill that in. And since this is a 45, 90 triangle, we want exact values. We can see that AB, or side C, is 5 times the square root of 2 inches. You could use Pythagorean theorem if you want. Do 5 squared plus 5 squared is 25, plus 25, which gives us 50, and the square root of 50 is 5 root 2. Okay. Here, question 2, we have another isosceles triangle, which means, and angle C is still 90 degrees, so A, B, and C, again, we're at 90 degrees here, which makes these both 45 degrees each. So A, B, and C angles are completed. So side BC, I wrote AB, one to right, side BC. Let's do side AC and side AB, or side C, right? So we know that this side A is already labeled. It's 7 root 2. 7 root 2 centimeters, which means side B is also 7 root 2 centimeters. So let's go ahead and fill that out on the triangle. Okay, so now since we already have 7 root 2, we see that root 2 on the side. Remember, our hypotenuse is root 2 times our side length. So 7 root 2 times root 2, that becomes 7 times 2, or 14. So our last side there, I'm going to just give ourselves a little more space, times square root 2 equals 7 times 2, which is 14 centimeters. So that's what we get for side C, 14 centimeters. Okay, question 3. Another isosceles triangle. So angle A continues to be 45 degrees. Angle B is 45 degrees. And angle C, we were told, is 90 degrees. I wrote 9 instead of C. There we go. So there's our 90, or 45, 45. I'll add those to the triangle above as well. So we see that the hypotenuse already has the square root 2, which means I want to divide by square root 2 to get my 2 side lengths. So it just leaves me with 13 meters each. So side BC, or A, is 13 meters. Side AC, or B, also 13 meters. And we already are given side AB, but I'll write it anyways just so we have it all together, 13 root 2 meters. Okay, question 4. Another isosceles, a right isosceles triangle. So we're dealing a lot with 45-degree angles here. So let's label our angle A, our angle B, both as 45 degrees, and our angle C as 90 degrees. So now let's find our side A, BC, so that's A, our side B, so it's AC, and our side C. Well, we're already told side C. We know the hypotenuse is 40 feet. So for these ones, since our hypotenuse is 40 feet, we want to divide them by square root 2 to get that other side. And then I want to rationalize. So I'm going to multiply by square root 2 over square root 2. So I get 40 root 2 over 2, or 20 root 2. Remember, you can always think of half of the hypotenuse times square root 2 as well. That works. It's a little faster, but that goes with memorization. And I always like to be able to do things without having to necessarily memorize a ton. So both of them come out to 20 root 2 feet. And I'll put feet after our 40. Okay, question 5. So, question 5. This time we have a 30-degree angle up at B. So let's do angle A, angle B, and angle C. Remember, the directions still apply that C is 90 degrees. And if B is 30 degrees, that makes A 60 degrees. So this is a 30, 60, 90 triangle. So it might be helpful to remember those ratios for 30, 60, 90. Right? If this is my 60, let's zoom up here and draw this a little better. Let's say this is my 60-degree angle and my 30. I'll put, let's do 2B here. Across from 30 would then be 1B. And across from 60 is square root of 3 times B. So those are good ratios to remember. I usually like to remember the hypotenuse as 1 as well, but either one is fine. Okay, so side A, side B, and side C. So we're already told side C is 14 centimeters, so we have the hypotenuse, which means the side across from 30 is half of 14, right? 14 over 2, which gives us 7 centimeters, and that's in the spot where B is. That's AC. So then we take this and we multiply by square root 3, which gives us 7 square root 3 centimeters. Okay, excellent. Question 6. Let's go angle A, angle B, and angle C. So angle A we are labeled as 60 degrees, which makes B 30, since C is 90. So again, we have a 30, 60, 90. So side BC, side AC, and side AB. So we're already given side AC or side B, right? We're told that that's 25 meters, and that's across from the 30-degree angle, which means the hypotenuse needs to be double that. So our hypotenuse, which is the C side, must be 50 meters. And across from the 60, we have to take that 25 meters and multiply it by root 3. So 25 root 3 meters. And we're all set. Question 7. So let's label our angle A as 60 degrees again. Angle B then is 30 degrees. And angle C is still 90. Okay, so this time we have our length across from the 60-degree angle. That is our side A. So side A is 9 root 3 feet. Since we already have the root 3 on it, it means the side across from our 30-degree angle must just be 9 feet. So AC, or side B for short, is 9 feet. And then the hypotenuse is always double that side that's across from the 30. So AB, right, side C, is double 9, which is 18 feet. So 18 feet. Question 8. We have angle A is not labeled, but we know angle B is 30 degrees, which makes angle A 60 degrees, since C is 90. So another 30, 60, 90 triangle. So let's go our side BC, side AC, and side AB. So we're given side A, right? We're given that BC side is 12, which is across from 60. So remember, the 30-degree side, we multiply by square root 3 to get that value. So that means to go backwards, we have to divide by square root 3. Now I always want to rationalize, so I'm going to do square root 3 over square root 3. So I get 12 root 3 divided by 3, or 4 root 3. So that is my side here. You can always double check, is 4 root 3 times root 3 12? Yes, it is. So our side B is 4 root 3, which makes our hypotenuse 8 root 3, because we're going to double that side. Okay, question 8 is all done. Let's move on to question 9. So question 9, a little different. It wants us to find this length AD, which certainly looks like it is exactly halfway. But let's go about starting with noticing that this is isosceles. So if that's isosceles, then this is also 16 feet. So we have those two lengths now. Now, more than this being isosceles, and it is a little hard to see with this diagram, but it gives us this length here, which means that this is an equilateral triangle. So triangle ABC is equilateral, since all sides are the same. Right, which means this whole side here is also 16. Now, because it's an equilateral triangle, I can make an assumption here that, well, I already wrote that that's also 16. Now, we do have to make some other assumptions as well. So let's assume, assume that AD, line segment AD, creates a 90-degree angle, so a right angle, with CB. That those two lines are perpendicular. So basically that AD is perpendicular to CB. Right, so we're going to put that this is 90 right here. It certainly looks that way, but this problem, we are just assuming that when we're solving this problem, so we want to make sure we kind of clarify that. So now, if that's 90 degrees, and remember, if this is an equilateral triangle, so all angles are also 60 degrees. So this means this angle is 60 right here and 60 right here. Now, if I draw a height, sort of this 90-degree angle from an equilateral triangle, it bisects these directly in half. So it's 30, 30. And it bisects these directly in half. So 8 and 8 instead of 16. So we have this 30, 60, 90 triangle with this side length of 8. So that means AD, let's go, so AD must be 8 times root 3 feet. If it is, I should say, if it is the altitude of triangle ACB or ABC. Okay. Question 9. Again, we see that we have all equilateral sides, which tells us that this is a square. So this is a square since all sides are equal. Are equal. Okay. Now, being a square means we have a bunch of 90-degree angles. Now, I drew a diagonal. So the diagonal right there, diagonal bisects an angle. So that means this is 45 degrees. And so is this. We have two 45-degree angles here. 45, 45. So it wants us to find AB, which really is just saying find one of the sides lengths. Well, what we really have here is a 45, 45, 90 triangle. So that's sort of what we've created with this diagonal. So that means because we have this 45, 45, 90 triangle, that this side length AB must be this 11 meters divided by square root 2. Or remember, you can cut it in half and multiply by square root 2. But I'm going to multiply by square root 2 over 2 since I don't want to use 5.5. So we get 11 square root 2 meters over 2. So AB is 11 square root 2 over 2 meters. And you can say 5.5 square root 2 meters if you prefer. Okay, let's move on to question. I'm accidentally highlighting my page. There we go. Question 11. Okay. So it reminds us that pi is a number here. It says, if you purchase pi gallons of gasoline, about how many gallons of gas did you buy? Well, since pi is approximately 3.14, we purchased about 3.14 gallons of gasoline. You can go to more decimal places if you want, but I think 3.14 is pretty standard for pi. So if you were paid 5 pi dollars per hour, about how many dollars would you make in 8 hours? So 5 pi dollars per hour, that means over 8 hours. 8 hours, then we should make 5 pi times 8. So 40 pi, right? So let's actually take our calculators out and calculate what 40 pi is. And if you only want to do 3 decimal places, you probably don't even need your calculator. You can just do 4 times 3.14, and then add that 0 on the end. So, but 40 times pi gives us about $125. And since we're talking about money, I'll go to 2 decimal places, 66 cents. Question 13. If you slept 2 pi hours each night, about how many hours of sleep do you get per night? So for here we get 2 times 3.14, or about 6.28 hours of sleep per night. Hopefully you are getting more than that, because that's not quite enough for most people. Okay, question 14. The directions say, is it possible to identify the location of a point on the edge of a circle in several... it is possible to identify the location of a point on the edge of a circle in several different ways. One way is to use the rectangular coordinate xy. In this activity, you will use a different method. You will be graphing words by using letters to identify points around a circle. The size of the rotation, or theta, will be the same, while the length of the radius will change. Okay, so we have a lot more directions or steps here. So it says 1, first select a word, avoid words containing 5 letters or multiples of 5. I'm choosing the word math, so notice that's a 4-letter word. Assign a number to each letter of your word according to the table below. So here's our table below. The numbers correspond to the concentric circles. You can begin on any spoke. Part 5 says, move from one spoke to the next in a positive rotation, right, counterclockwise. Part 6 says, make a dot at the intersection of the spoke and the circle corresponding with the number of the letter you are on. Part 7 says, keep graphing the same word until the last letter of the word lands on the spoke that you started on. You will need to make more than one rotation of the circle in order to close your figure. So, circle numbers and their corresponding letters. The letters for math are underlined, right? So we'll stick with math for this answer key, but you could have done a lot of different words here. So there's the A, H, T. Not in that order, obviously, but there we go. Okay. The word math, we'll use the numbered circles 4, 1, 3, 2 in that order, right? So 4, because here's our math, right? The M. So 4 is our first one. 4A, so 4, 1. T, 3. And then H is the last one. So 2 is sort of our last one. So circles 4, 1, 3, 2 in that order. You can bring on any spoke. You can begin on any spoke. So remember, we can start anywhere as long as we follow that order. I began on the spoke with the numbers. I made a dot on 4, rotated the next spoke and made a dot on 1. I connected the 2 dots. Then I moved to circle 3, made a dot, connected the segment, and moved to circle 2. You can see math marked on the diagram. After marking H, I started over with M on the next spoke. And it says, see the dotted line. Continue spelling math and rotating around the circle until the figure is closed and the path repeats itself. The figure at the right is completed graph on the word math. I always knew math was beautiful. Okay, so let's look. So, like it said, we see a little dotted line there. So it says we see the dotted line, and it says I began on the spoke with the numbers, right? I highlighted that above. I began on the spoke with the numbers. So it looks like this one begins right at 4 there. And remember our order, I'll rewrite our order here. 4, 1, 3, 2. So notice that the next spoke up, that's on the first one, or 1. Here's 1, 2, 3. So there's the 3, M-A-T. And lastly is 2, right? 1, 2. So now that we've completed one full cycle, you go back to 4. So restart at 4, right? 4. And then the next one would be 1. So our next spoke down, we're going to be all the way over here. That's representing the A again. Then we're 3 out, so 1, 2, 3, right? 1, 2, 3. So that's where the T would be. And then we're on 2. So 1, 2 is that H. So if we were to keep connecting A, T, H, and now this shows the finished one over here. And notice it does overlap. So as it overlaps more and more, it does get a little bit more challenging to see. But that's where you see our A. And that's where you see our T. And this is where you see our H. So there's that M, A, T, H. I'll do that do each sequence in like its own color. So M, A, M to A, to T to H. So that's that sequence. Remember that came after the first sequence. So I'll do the first sequence in right here. So M, A, T, H, and then we started again with that. I'll put this in that grouping. So we just keep following this pattern, and you can see how it closes, but I'll walk through the rest of it as well. So we ended on H, which means we have to go back to 4. So here's our 1, 2, 3, right? That's the 4th spoke. So there's the 4. So 4, 1 for our A. There's our A. 3. So here's the 3. So we're connected to that 3. We see that right there. And then lastly, 2. So we haven't connected yet, which is why we're still going. So there's another sequence. So let's do another one. We ended on 2, so we go back to 4. So here's our 4. So we have to do that, our M representing our M. 4, 1. So our next spoke, we're 1 right here. 3. So 1, 2, 3, we're right here. We are starting to really overlap. And then lastly, 2. So here's our 2 right there. So there's another sequence of MATH. Again, we haven't connected yet, so we have to keep going. Let's do this light blue color next, I guess. So we start back at 4. So this is our M, right? So M. A was 1. So we go all the way down here to 1. T was 3. So 1, 2, 3. We're right here. And then lastly 2. So 1, 2. So again, we still haven't quite connected yet. But on this very last one, we finally connect. Let me do this one in a fun rainbow color because it's connected. When we go back to M, we've made this connection. So last connecting piece. That's that sort of last connecting piece. Okay. So again, you could have done this with any letter, any word. Sorry. Okay. So now it's your turn. Select a word. Short ones are best. Assign the numbers and begin. There are so many possible answers. So many answers. Let's do the word D-R-A-W. It's a 4-letter word. We're drawing, so why not? That's the first one that came to my mind. So let's look up and find our D. So our D is on circle 1. So there's our D. Our R is circle 4. So R is 4. Our A is circle 1. And our W, where's our W? Is circle 4. So let's pause and review these directions and make sure that it's okay that we're picking things on the same circle. So if we look at one, it says first select a word, Void containing 5-letter words or multiple of 5, so we're good there. We didn't do that. Assign a number to each letter. We did that. The numbers corresponding to the concentric circles. Right, that means circles with the same radius, so which was what we see when we look down at the graphs. You can begin on any spoke. Okay. Move from one spoke to the next in a positive direction, so we did that. Make a dot at the intersection of the spoke and the circle corresponding to the number. Okay. Keep graphing the same word until the last letter of the word lands on the spoke that you start on. You will need to make more than one rotation of the circle in order to close your figure. So it doesn't say that we can't have something with multiple letters on the same. So let's stick with this word. Let's stick with draw 1 4 1 4. And I'll start where we started before. We didn't have to, but I'll start on spoke 1, and then we go all the way out to 4, and then back to 1. So 1 4 1, and back to 4. That's my D R A W. So now we go back to 1. I'll change my color every time I kind of finish one segment. So back to 1. Remember, we're rotating counterclockwise. So that's my D again. And then my R. And then my A. And then my W is all the way back out at 4. Okay. So now we start over. D is back to 1. So here's my D, my R, my A is right here, and my W. Draw. Okay, now let's switch our color again. So we're back to 1. So D, R. Then we're back to 1 again. A. Then to R, W. So here's where we meet up again. So we have finished this segment because we finally met up with something with a point that was already on our graph. So this one, pretty quick one. We had to go around more than once, but not too many times. Again, if you have multiple different words, you're going to get different answers. So it says word 2. So we're going to pick another word. So let's look up and let's try to pick one that is on more than just 2 of the concentric circles. So let's look at our letters. We just did 4-letter words twice. So let's do dog. I'm sitting here and my dog is by my feet, so it's on my mind. So D is dice 1, O is dice 4, and where's our G? G is dice 2. Good. So we're on 3 different dice. So dog 1 4 2. Okay. Dog 1 4 2. Let me rewrite that down in front of our graph as well. Again, you don't have to start on the one with the numbers. You could start anywhere. Let's start there. So 1 4 2. So 1 4 2. Right? D O G. Okay. Let's go with this color. So we're going to go back to 1, and then 4 again, and then 2. So 1 to 4 to 2. Okay. So we're going to go 1 to 4 to 2. Okay. And then 1 to 4 to 2. So we're starting to overlap now. And then we're back to 1, then 4. So I'm going to connect as I go so I don't lose these. And then here's our 2. 1 4 2. There we go. We haven't met up yet. So 1 is our next one. We're right here to 4. So there's 1, 4, and then here's our 2. Okay. I'm going to run out of colors. Let's do yellow, I suppose. So 1, 4, and then 2. So we still haven't met up. So 3-letter word is actually taking us quite a while to meet up. That's okay. Let's go with this fun one. So 1 to 4. 1, 4 to 2 right here. 1, 4, 2. Okay. And again, depending on the word, you might be done. So 1 to 4 to 2. And I did kind of also intentionally pick one that did have a lot so we can really see it progress. Let's go with this fun color. Okay. 1 to 4. So 1 to 4 to 2. And now we're finally about to connect on this last segment. I'll do it in black, where we go 1 again. So we've reconnected. So this one took a lot of rotations, but there is our shape. Okay. Question 16 says, what is the angle between each spoke on the grid above? So we have to count the grids for this. We need to, count the spokes. So let's see, I'll try to pick the least messy graph here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 total spokes, right? So 10 total spokes. So what is the angle between each spoke? Well, if there's 10 total, let's think how we need to break that up. Remember, so a whole circle is 360. So we're breaking those spokes up, those 360 degrees up into 10 segments. So each one is 36 degrees between. Okay, how many degrees did it take to make the word math once? Well, we had to go over 4 spokes, right? So let's see, where's that math one? So let's highlight that 1. So I'm going to do that much smaller. And there we go. So there's 36, there's another 36, and another 36 right there. So we can add those lengths up together, those measurements up. So if we do 36 plus 36 plus 36, we get 36 times 3 essentially. So 36 times 3, which, what is that, 108? Yeah, 108 degrees. 90 plus 18, yeah. Okay, how many degrees did it take to go to math and then restart another one? So it's just another, now we're going to 4 instead. So that would be 144 degrees. So just one more. How many times did I need to spell the word math to complete the graph? Well, we did already walk through that, but let's go and look, right? So we color coded, so it'll be nice and easy to count. But we don't need to necessarily count each spoke that we touch if we think about it logically, but let's count. So here we see the highlight in blue is 1, and then we see this another one, and sort of the dotted line to darker blue is 2. Then our green is 3, our orange is 4, this light blue is 5, and then we just connected them. So we needed to do it 5 times. So how many times we need to spell the word? 5 times. And how many revolutions did it take? That was 2 revolutions. So we went around twice in order to do that. So we said we could do this without counting. In fact, B says, can you figure this answer out without counting? Yes, we can figure these answers out without counting, right? Let's think of that 5. So we said there's 10 spokes. 10 spokes. And it takes 4 spokes to spell math. Okay. So we need to know when these kind of have multiples of each other. That's when they start repeating. So the least common multiple is when they start connecting. So the least common multiple of those is, let's see, 20. Yeah, 20 is our least common multiple. Well, that's how many spokes we need. So if there's 10 spokes total, so 20 spokes needed. Well, we could figure out part A by saying, oh, okay, we need to divide that by the 10 total. 10 total, which means 2 revolutions. We could also figure out the 5 times using that same concept. 20 spokes needed. And math is 4 spokes for math. For math, which is 5 words, or 5 times, I should say. 5 times. So that's how we could have figured out question 19 as well. Okay. Question 21 says divide out the common factors. So to do that, we actually do have to factor it. So let's look for greatest common factors first. And it's always a good plan. So 6x squared and 30x squared has a greatest common factor of 6x, which leaves us with x minus 5. And then here we have a greatest common factor of 3, which gives us x squared minus 25. And I can factor that a little bit more, right? I can make this 6x times x minus 5 over, well, here we have a difference of squares. So 3 times x minus 5 times x plus 5. So now let's find our common factors. We have these x minus 5 as factors in the top and bottom. So those can certainly reduce. And 6 and 3, well, 6 divided by 3, we end up with just a 2. I'm going to put it on top instead. So that our final answer, after we divide out the common factor, is 2x divided by x plus 5. Okay, let's go down to question 20. Question 22. Sorry. It says perform the indicated operations. Divide out all common factors in your answer. So this one wants us to multiply in question 22. But just like above, let's reduce whenever we can. 9x to the third. No, there's no greatest common factor there because it's only one term. But here I can factor out an 8 and get x plus 4 in parentheses. And here I can factor out 2 and get x plus 4 in parentheses in that second numerator. And here there's nothing to factor out, so let's leave it as negative 3x to the fourth. So now let's find our common factors. We have x plus 4 in top and bottom, so those can certainly reduce. And then we also have 2 and 8, so they're both divisible by 2. This goes away entirely. We're left with 1. In this one, 8 divided by 2, we're left with 4. Okay, let's look at our x's. I have 4 x's here and 3 here, which means this goes away. And here we're left with just x to the first, or just x. And then lastly, let me use this one. Negative 3 and 9. I can make this 3. I was going to get rid of the negative first, but I'll divide both by negative 3, which gives it a positive 1, and this makes this a negative 3. So make sure you're being really neat if you're going to do it the way I just did it. It's never a bad idea to do it in more chunks too. But here we're left with negative 3 times 1 on top. So just negative 3 on top. And we're left with 4 times 1x on bottom. So 4x. There we go. Okay. This one we're dividing. So remember, we're going to multiply by the reciprocal. So we can factor as we go. The top is going to stay 6x. But let's factor this bottom. So 2x squared, which means we're probably going to have a 2x and a 2x. Now factors of 9, we can have 1 and 9. Not another 2x, just an x. We're going to have 1 and 9 or 3 and 3. Sometimes let's start with this one. This is a difference of squares, so I can say it's 2x minus 3 times 2x plus 3. It's a pretty good sign that one of these will be the same. So let's put a 3 here into 3 here. So here, if I do 2 times 3, I get positive 6 if I plus sign, and minus 3 if I put the negative there. So those do multiply to 2x squared plus 3x minus sign. So we're all set there. So I'm going to write 2x minus 3 times x plus 3. X plus 3. Now I'm going to multiply this time. So I'm going to multiply by the reciprocal of this second fraction. So 2x minus 3 times 2x plus 3. And then I have 6x in the denominator now. So, nope, sorry, not 6x, 8x to the 4th. 8x to the 4th in the denominator now. So let's see what cancels. So 2x minus 3 and 2x minus 3, since those are the same, we can reduce those. We have 8 and 6. Those both have a factor of 2, so I can divide each one by 2 to make this 3 and make this one 4. And since I have an x, I can cancel that out and reduce this one to x to the 3rd. So let's see what we have so far. And it's okay if you miss something, you can always keep checking as you go. But we have a 3 left in the numerator there. So times 2x plus 3. And over here we have a 4x cubed. And we have an x plus 3. So nothing else reduces, so we're going to leave that as our final answer. Okay, question 24. Question 24, we're adding this time. And our denominators are super close to being the same, right? X minus 5, 5 minus x. So the only thing we really need to do here is factor out a negative from either one. So this can become, let's factor out a negative. This can become negative x minus 5. I can factor out that negative, and I'll do it in a few steps actually. I'll do it negative, and then it's negative 5 plus x. And then I can show that I can just flip that order to make it x minus 5. So now they're the same. So I haven't changed this part at all. But now this negative, I can just attribute that to the top. It doesn't have to be stuck on the bottom. So I can say 3x over x minus 5 plus negative x over x minus 5. I haven't changed my fraction at all by moving the negative sign up there. So, since my denominators are the same, I can add my tops together. So plus a negative, that is going to become 2x over x minus 5. There we go. And our last question of the worksheet, we have question 25, we're adding. So our denominators are actually already the same. So those are already the same. We can factor them now, or we can factor them after we add the numerators. Let's just add our numerators first and then factor. So since our denominators are the same, I don't need to change anything, right? They're already the same denominator. So I can say x squared minus 8x plus 3x minus 14 all as one fraction now. So now let's combine our like terms. So x squared plus 10x plus 16. This becomes x squared minus 5x minus 14. So our last step is to see if we can factor and reduce here. So factors of negative 14 that add to negative 5. Well, that would be 2 times negative 7. I'll write it a little closer. So I'm going to do x plus 2 times x minus 7. Those add to negative 5 and multiply to 14. Now factors of 16 that add to 10, right? So there's 2 times 8. So x plus 2 times x minus 8. And since we have an x plus 2 on the top and the bottom, we can reduce this to x minus 7 over x minus 8. So we have added and reduced. All right, hopefully you found this video helpful. Thank you for watching.